In this video, we're going to be looking at finding the rate or time in a word problem on continuous exponential growth or decay. We're going to be using this formula for continuous exponential growth or decay. And we have these things labeled. So A is the amount after some time has passed, or the final amount. A sub 0 is going to be the initial amount, the original amount. E is a constant known as Euler's number. That's one that if we need to, we can plug into the calculator. R is the rate, and if it's growth, it's going to be a positive number. If it's decay, it's going to be a negative number, and T is time. Okay, so let's take a look at this first problem. Suppose the number of bacteria in a certain population increases according to a continuous exponential growth model. A sample of 1,400 bacteria selected from this population reached the size of 1,587 bacteria in 4 hours. Find the hourly growth rate. So R is what we don't know. Okay, we know that the initial amount is equal to 1,400. We know the amount after time is 1,587, and we know that time is equal to 4 hours. Okay, so we can put this in the formula. We get 1,587 equals 1,400 E to the RT. Okay, we have T, that's 4, so it's 4R. Okay, there's the equation that we're going to try to solve. Now we need to move this over by dividing it. So I'll divide both sides by the 1,400. That gives me 1,587 over 1,400 equals E to the 4R. And now in order to get rid of the E, I'm going to apply a logarithm to both sides. So I'm going to put an ln in front of both of these, which will cancel out the E. Okay, so that will give me ln of 1,587 divided by 1,400. And then the other side will be 4R. So if I divide the 4 over, I'll get my final equation that R is equal to ln of 1,587 over 14 divided by 4. So I divided 4 on both sides there. Okay, at that point, we need to go to our calculator. So let's go to the calculator, oops, and type this in. So here's ln 1587 divided by 1400 divided by 4. Okay, we got to round to the nearest hundredths. So R is equal to 0.03. Here's the hundredth, and the next number to it is not bigger than 5, so we leave it alone. And if we wanted to write that as a percent, it would be 3%. So the rate was 3%. All right, let's look at the next problem. Okay, so we have $2,100 is initially invested in an account at a fixed rate, compounded continuously. After 5 years, the amount of the money in the account is $2,444. Find the interest rate per year. Okay, so we don't know the interest rate again. So we do know that the initial amount is 2,100. The amount after time is 2,444. And the time is 5 years. Okay, so we can set this up. It'll be 2,444 equals 2,100 E to the, we have the T in the exponent, which is 5, but we don't have the R, so 5R. Okay, let's divide both sides by 2,100. Okay, and that will give me, this will cancel, so 2,444 divided by 2,100 is equal to E to the 5R. Now, if I apply an ln to both sides here, I can get rid of this E. So that will give me ln of 444 divided by 2,100 equals 5R. And if I divide that 5 on both sides, I'll get ln of 2,444 divided by 2,100, all divided by 5 equals R. And again, let's go to our calculator. So ln 2,444 divided by 2,100, whoops, divided by 5. Okay, so our rate is going to be very similar to our other rate. And let's see, look at the hundredths. It doesn't round up, so our rate is equal to 0.03, which could be written as decimal. So R is equal to 0.03, or R is equal to 3%. Okay, let's take a look at this last problem. It's a little bit different than the first two. Okay, so the mass of a radioactive substance follows a continuous exponential decay model with a decay rate parameter of 5.3% per day. Find the half-life of this substance. Okay, so a couple things we need to think about here. First of all, decay. That means my rate is negative. So R is going to be less than 0. We have 5.3%. We don't have any other information, but we do have this, find the half-life. So we need to know what half-life means. And what half-life means is that if you're decaying, how much time will it take to get half of what you started with? So for half-life, this means that how long does it take for A to turn into 1/2 of the original amount? Okay, so half-life is when A is equal to 1/2 of the initial amount. So we can make this substitution in that formula. A is equal to A naught e to the RT, or A sub 0 e to the RT. We can replace this A right here with this 1/2 initial, okay, because it's half-life. So you get 1/2 of A sub 0 equals A sub 0 e to the RT. That's what half-life means. And what you can do next to make this problem doable is that you can divide both sides by that A sub 0 and it goes away. So you're actually setting, you're ignoring all the numbers, you're just doing 1/2 is equal to e to the RT. So 1/2 is equal to e to the RT, and our rate is 5.3. As a decimal, that would be 0.053. And since it's decay, we got to put a negative sign on that rate. And then t is what we're looking for. How long will it take it to get half of its life over with? Okay, so we can now solve this by applying ln. That one goes away on the other side. So we get ln of 1/2 is equal to negative 0.053t. And then when we divide both sides by negative 0.053, we get t is equal to ln of 1/2 divided by negative 0.053, which we can put in our calculator. ln of 0.5, or you can type in 1/2, whatever, divided by negative 0.053. Okay, and remember we're rounding to the nearest hundredth, so it's going to be 13.08 because this 7 rounds up with that 8 right next to it. So 13.08, and that's how long it will take to reach its half-life.